Hello students, welcome back to this new session. Here I have come up with one more problem on Euler's predictor character formula. You can just read the problem here. Using Euler's predictor character formula, compute y of 1.1 correct to 5 decimal places given that dy by dx plus y by x is equal to 1 by x square and y of 1 is equal to 1, that is the initial condition. So let's take down the given equation and try to solve it by that method. So you have dy by dx plus y divided by x is equals to 1 by x square. Separate your dy by dx from here by taking the y by x to the right hand side. So dy by dx, so I'll write here, this implies dy by dx is equal to 1 by x square minus y by x. Now if you take the LCM, sorry it's y by x. Now if you take the LCM, so here it will be 1 minus xy over x square after simplification. So once you get that, this is going to be your f of xy. So this is your f of xy. Just keep it aside. Now you have to work for, it's given that x naught is equal to 1. It's given already, y of 1 is equal to 1. So it is y naught is also 1. And at what value you have to work for y? That is 1.1. At 1.1 you are supposed to work for the value of y. Initial value is 1. So definitely h should be the difference between them, which is 0.1. So you have to take that difference because it is not mentioned as in the previous problem. You have to take the value for h as 0.1. Okay, it has not been mentioned anything. So just take the value of h to be 0.1 as you just identify. Even if it is not given, this is how you find it. Now you want to work for y at y of x1, which is y of x naught plus h. Okay, so y of 1.1 is a question mark for you. Okay, is it? Down, you know that y of x1 by the formula, by Euler's, I will write here, by Euler's I say formula or predictor formula, you can say. I'm just writing here Euler's formula. So it's equal to what? It is y of x1. So I'm going to write y of x1 to be as y1, I will say. Okay, let this to be y1. Okay, so y1 initial approximation. We have learned this in the previous session also. You write y1 initial approximation by y1 to the power 0 in a bracket, is it? So, and it's actually called y1 initial approximation. This we have already learnt in previous session, so I'm just continuing with that. Okay, so y1 initial approximation is y naught by the formula h times f of x naught y naught. Now before going for using the formula, initial things we need to do, I just didn't do it, I'll just continue it here and keep it aside. Y of x naught y naught, it is equal to, sorry, f of x naught y naught is equal to f of 1 comma 1, you can say. Is it? Because x naught is also 1, y naught is also 1. And how is f of xy defined? It is 1 minus x into y, which is 1 minus 1 divided by x square, which is 1 square. So 1 minus 1, it will be 0. So f of x naught y naught is 0. So this one thing is there with you. So keep it aside, all of you. So it will be what? Y naught is what? Y naught is 1 plus h value is what? It's 0.1. F of x naught y naught, it's already 0. So this gives you the value for y naught initial approximation to be 1. I hope it is clear to all of you. Similarly, by modified Euler's formula or character formula, you can say, modified Euler's formula also or character formula also, it is said. Modified Euler's formula, we have what? We keep on increasing its accuracy, is it not? We keep on doing its accuracy part. Okay, so y1 first approximation, it is defined to be y naught plus h over 2 times f of x naught y naught plus f of x naught, sorry, not x naught, it's x1 comma y1 initial approximation you do. This we have learned already in the previous session, so just You can write it from there itself. The formula I have given, I am directly taking those formulas here. Okay. So y0 is 1 plus h is 0.1 divided by 2. F of x0 y0 is 0. F of x1, so x1 is 1.1 comma y1 initial approximation is 1. Just see this. So it's going to be as per the definition. If you simplify this, it is 0.05 into 0 plus this, it's f of 1.1 comma that. So how is it defined? It is 1 minus 1.1 into 1 over x square. X square is 1.1 square you get. Okay, simplify this using your calci. If you do the simplification, you will end up with 0.9959. Similarly, let us go for one more iteration. Y1 second approximation. Y0 plus h by 2. F of x0 y0 plus f of x1. What is the recently evaluated value for y1? It's y1 first approximation, is it? So write that. Y0 is 1. H is 0.1 divided by 2, so 0.05. This retains same. F of x0 y0 is already 0. So 0 plus f of x1 is 1.1 comma 0.9959. Okay, now use your definition here, which is 1 plus 0.05. It's this is however 0. Simplified part for this, it is 1 minus x into y, which is 1.1 into 0.9959 over x square, 1.1 square you get here. Just see. And the value, simplified value for this is 0.99605. This is the 5th decimal place this time I have got. Okay. Now let us again continue with one more iteration, so that, because it has been mentioned correct to 5 decimal places, let us go for one more iteration so that these 5 decimal places repeat in that iteration. So correct to 5 decimal places, I hope you have understood. Previously I have explained the meaning of it. For 2 consecutive steps, the decimal places values you should get. Use the formula here again and simplify it. Okay, so y0 is 1, 0.05 here. This at least is 0 plus f of 1.1 comma, the recent value is 0.990605. Okay, complete the bracket and simplify this. 1 minute. It's 1 plus 0.05 into 1 minus 1.1 into 0.99605 divided by 1.1 square you get. So the simplified value for this, after substituting the values in the calc, is 0.99605 only. The value is, now these decimal places for these 2 consecutive steps, for second approximation and for the third approximation, they are appearing same. Okay, so this up to 5 decimal places we have got the correct answer. Okay, I hope this is clear to all of you. Continue in my next session with a new method of solving the linear differential equations, but just write the final answer for this. Therefore we were working for y of 1.1, I guess. Yeah, y of 1.1 is equal to, it's 0.99605. Correct to 5 decimal places, it is this. This completes the solution. Continue in my next session. Thank you.